Hello students, in this chapter 2.6 or chapter section, we're going to go over the graphs of basic functions. We're going to learn a little bit about their features and the simplest form of the graph of these functions, which are called parent functions. I would like to review with you the different grouping symbols we have. The inclusive, which are the brackets on the left, the ones in color black. That's for when you include the point. I don't know if you remember that I went a little bit over some other representations of these grouping symbols. Is when you have a filled point in your graph, when your graph looks continuous, where when you have less than or equal to or greater than or equal to. These grouping symbols include the point. For the parentheses, it's called exclusive. It's an open interval. It's when you have an open point in your graph, meaning that you don't touch the point. It could be a jump. It could be a discontinuity. We're going to learn about that in this video. It's also when you just have less than or greater than, not equal to. And we always use the exclusive grouping symbol, which is the parentheses with infinity, whether it's positive or negative. We cannot reach infinity, so we do not touch infinity. This is a very informal definition, but let's go over the definition of continuity. A function is continuous over an interval of its domain. Notice we're talking about the domain, which is the x values. If when you're drawing the graph over whatever interval you're talking about, you can graph your function or sketch the drawing without lifting the pencil from the paper. In other words, you will never stop drawing. For example, for this particular function, if I want to graph it, I'm going to come from the left, but then I have to lift my pencil at x is equal to 2 to keep on graphing it, which means this function is discontinuous at x is equal to 2. Notice how we focus on the x value. We're talking about the domain. This graph is discontinuous at x is equal to 2. We have three main different types of discontinuities. We have jump discontinuity, which is the one that we saw, where your graph jumps from one point and keeps on going on a different part of your graph, but on the same value. It stopped at close to 2 over here, it's an open point, and then it continued on the filled point. We have an infinite discontinuity. In this case, if you can see, my discontinuity is at x is equal to 0. My graph will never touch this line from the left nor from the right side of my graph. And we have a removable discontinuity when your graph looks like a line, looks like a straight line, but you have a removable point, a hole in your graph. We call this holes. Oh, sorry, with an H alone, sorry, hole. In other words, this graph is discontinuous at 2, this graph is discontinuous at 0, and this graph is discontinuous at x is equal to 3.